Hi all. Today we will see these four things today. One is read write without pole and read write with pole. So what is advantage we will get when we use pole, that we will see. And then while opening a file we can open it using using the flags like read only, write only, or read write, or so those flags we can give. Apart from that, one more flag we can give, that is non-block. So like what this flag is, when to use it, we will see that. And then we will also run Scull Pipe code and then check how the read and write will work with pole. So that's what we will see today. So read and write are blocking calls, means if at all data to read is not available, then the process will be put to sleep, and whenever the data is available, the process will be woken up. So that's one thing. And write also same thing. If the output buffer where the write has to happen is full, then the process will be blocked, and when there are buffer space is there in the buffer, then the write will be woken up and the write will happen. So these are blocking calls. Read and write are blocking calls. So what is the problem with these is, so if at all we have some two devices, we are opening two devices, for example MyDev1 we are opening in read mode and MyDev2 we are opening in read mode. But the problem is MyDev1 the data to read is not available, but for MyDev2 data is available. But what is happening is we are calling FD1, the device 1 read first, then device 2's read. So device 2 data is there to read, but device 1 data is not there to read. But since we are calling this first, the process will block here itself and it will never reach here. So once the data is available here to read, then only this will be executed coming out of the sleep, and then it will be executed, and then after that only this will be executed. So this is one drawback, because the data is available right here. So why don't we execute this next instead of waiting for this? So that's what is being solved by pole. If you see here, this is Scull Pipe pole code. So if you see here, what we have to do is, while opening the file, after opening the file, we have to put it in this structure, pole FD structure. The file pointer we are passing into this structure, and then we are setting the event as whenever there is a read is happening, the data is ready to read, then please read the data, like that you are doing. So what is happening is we are calling first pole instead of calling read. Before read we are calling pole. So what is this one means, we are waiting, we have given only one file descriptor here. Since we have given one file descriptor, we can give many file descriptors also. For example, like this we can give two file descriptors also, like FD1, FD2. So we can define as 2 here, and then 0th one we can give one file descriptor, and one we can give another file descriptor. So in this case what we are giving is, we have defined this pole FD structure and only one file descriptor we have given. So we are calling pole. So for this device, the first function call, system call that is going to be called is pole. So after that only read will come. So now what will pole, when pole is called, what happens is, if you see here, this is the driver code. So when pole is called, this particular function will be called, okay, of the driver will be called. So what is happening is, so semaphore it is acquiring, down semaphore means semaphore is acquired. Then what is happening is, if at all there is no data to read, then wait in this buffer. If the output buffer is full and we are not able to write, then wait in this buffer. So that's what we are defining. So our structure is having these things. So this is our device driver structure. For this device driver, these are the various structure fields that are needed. So one is in queue. Whenever we are performing read and there is no data to read, we will wait in this particular queue. This is wait queue. We will wait in this queue. Whenever there is a write and the buffer is full, we will wait in this out queue. This is buffer. This is a circular buffer. End is end of that circular buffer. Read is from where in that circular buffer we are starting to read, and write is from where in the circular buffer we are starting to write. And buffer size is size of the buffer. Semaphore we are giving one semaphore we are taking. So if you see, init is there, right? Init of this, we are alloc chart region. Here the major number is assigned to that particular device by the kernel itself. So we are not assigning any major number. Major number is given by the kernel. Then cdev init we are doing, cdev add we are doing, and after that the buffer we are this is calloc we are doing. Buffer size we are buffer size is how much? Buffer is I told you circular buffer, that calloc we are doing. And then end buffer is dev buffer input pointer, what is the pointer here got, plus buffer size, end of the circular buffer. Read and write pointers are to the beginning of the circular buffer we have assigned. And init wait queue we have assigned head as assigned to this one, and init wait queue head as assigned to this one. Semaphore also we initialize to 1. So semaphore we have to initialize to 1 because so whenever we want to acquire the semaphore and enter into critical section, we will decrement this and this will become 0. So initialization we have to start from 1. So at any one with this semaphore 1 means at any time only one process will be allowed to enter into the critical section. 1 means. So that's the idea. So that's the init. Actually this cdev init should come, I think, after all these initializations. It has to come cdev add. So I think since we are okay, anyway, okay, this is the code that has been generated by ChatGPT. So I think some mistake it has done. So this has to come after all these initializations. After here it has to come. So this is the one thing. So that is done. So now this is the user process that is called. This is the device that it is opening in the read mode. The first function, and we are assigning it into the poll's poll fd structure, this function pointer, this file pointer, and then we are calling poll. So when poll is called, the first function that is called is poll, and this is the one it is called. Semaphore is acquired. So now we are entering into the critical section. So poll wait, since there is no data to read, this will wait in this particular queue. Okay, since there is no data if at all there is the output buffer is full and there is no space to write, then we will wait in this queue. That's what it means. So since there is no data to read, this will wait here. So the poll is when first executed, what happens is, so when RP and WP are same, right? We have init we have done, right? RP and WP are same. So this is failing, this will fail. Space to free space is there to write is available, right? We have not written anything, so free space is available. Entire buffer is available. So entire buffer is available. So this is also will fail. So both these if conditions will fail. So mask is first initialized to 0. So since these things have failed, mask value will remain 0. So we are up means we are giving up the semaphore. So we are coming out of the critical section, and then we are returning as 0. So since mask is 0, this poll has returned 0. So what happens is whenever poll returns 0, this process is put to sleep. So this process is put to sleep. So now what happens is I will do. So then now this I will try to run this now. So if you see here, so this is our test poll that I have shown you, right? This is the test poll that I have shown you. This is the user space process that is there. So first function call that is for kernel system call that is doing is poll, and because there is no data to read, this will block here. Poll has returned 0 and it will block here. So system will the process will go into sleep. So what I will do is I will first driver I have to build, right? So first I will do make I will do. So driver is built now. So make file is there, which is used to build the driver. So now driver is built. If you see -l, one KO file will be there. So this is the driver. So next what you have to do is we have to build our process. So that I will build now. So process we have built. So if you do -l, so process is also come. So where is that? This one, test poll is our process. So next what we have to do is insmod we have to do. We have to insert this module into the kernel. That's what we are doing now. So we're inserting the module into the kernel. So module has been inserted. Now we have to check the major number. So since the kernel assigns the major numbers, we have to check the major number. So cat /proc /devices pipe grep Scull. So 239 is the major number of that particular device. So now what we have to do is we have to make a node with that major number. 239 I have to take this major number. So we are making a node. So we will make the node. So node has been made. Now we have to give the permissions, read, write, execute permissions to this particular node. So that we will do. That is also done now. Now what you will do is we have to run this user process we have to run. So now first function call, first system call that it will make is poll. So and it will wait there because poll has returned 0 because that there is nothing to read. So that's the reason why it will wait here. So waiting for data using poll. If you see here, poll has returned 0 and so the process has been put to sleep. So this process has been put to sleep. Now what I will do is I will do echo. I will write into this device. I will open one other terminal and write to this device. So I will open one other terminal and then I will write into this device. So this device is there. I am writing hello Cyclone to this device. So now what happens is something is written into this. So first this write is happening, right? So the write system call will be called. So this will be called, Scull Pipe write will be called. So now what happens is first it will acquire the semaphore, down interruptible, they acquire the semaphore, it is entered into critical section. Space, is space available? Yes, space is available, it is not 0, space is available, full space is available, nothing is written into the device so far. So space is available, so this while loop will be not be going into this while loop, it will come here. So now what is the write pointer is to and write read pointer at the same space. So this condition will be true. The entire condition will be true. Since we are initializing, we are both the write pointer and read pointer at the same point. So now what you will do is end and then whichever is the maximum. So count is whichever is minimum. Count is minimum or the circular buffer is minimum. Circular buffer size is minimum. Whichever is minimum, that will it will take, and then copy from user to the write pointer, wherever is write pointer, from there you will write it. And then after that what it will do is write pointer it will increment. So next write will happen from wherever the previous write has happened. So next it will happen from there, and then if it is come to the end of the buffer, then it will we will assign it to the beginning of the buffer. And then up means we are giving up the semaphore, but this means the critical section is over. We are coming out of the critical section. Now this is important. Wake up interruptible. So this is where the read is waiting. Actually, this is the in queue means this is where the read is waiting. So wake up. So this will wake up the process, all the processes which are waiting in the in queue for read for data to read, whichever is the process that is waiting for data to read. All the process it will wake. In our case, there is only one process that is waiting in this queue. So now what happens is, so if you see here, this is what is happening. So if you see here, terminal 1 poll is first called. Poll has returned 0. Scull Pipe is no data, sleep on in queue. Terminal 2 we are sending echo p write, wake up interruptible, the interruptible in queue it is done. Poll wakes up now. Now poll will wake up now, and kernel again calls poll. So poll will wake up and kernel again calls poll. So now again poll is called. So poll is called means this is called. So now what happens is, now here this will fail because write pointer has incremented, plus count it has done, right? So read pointer is still at the beginning, write pointer is there. So this mask will not be 0 this time. Previous it was 0, right? This time it will not be 0. So now what happens? Scull Pipe returns poll in. So terminal 1 will So it will come out of this pole and it will start executing the next instruction that is there in the process. This will instruct, and then the read will be executed. Okay, so that's the thing that is happening. So now we will see it. So now I am doing, so this is still waiting here. The seed is put to sleep. Now I am writing into this. So if you see here, so pole returned the data available, read hello Sai Kiran. Pole returned and data available, hello Sai Kiran is reading here. So now again I will write something. What is the buffer size that you have given here? Buffer size we have given as 1024. So okay. So we will write one more thing. Another process will be there, right? Okay. So this will be again the same thing. Okay. So okay. No need of writing. So now what happens is, so this is the thing. So now read has come, read has happened. So read, what will happen? Read system call, we have to go here and see, check what is there in read. So read will come here. Read will down interpret, it will acquire the semaphore, it will enter into critical section. Dev is equal to, this is not equal. Right has been incremented, right pointer has been incremented, this is not equal. This while loop it will not enter, it will come here. And then dev pointer, right pointer is greater than read pointer. Yes, exactly. The right pointer has been incremented, so it is greater. So this will go here. Minimum of these two things we will find. And then it will copy to user. From here to buffer it will copy. And then what it will do, read pointer it will increment. And then if it has come to the end, then it will set to the beginning. And then up means it will give up the semaphore. So it out of critical section has come. Wake up interruptible. So wake up interruptible means, so whatever is now read has been completed. So if at all something, if at all read has been completed, so means the buffer is empty now. So something can be written. So that is why it is waking up all the process that are waiting for the write buffer to be emptied. So that all the process will be waken up. So because since our case the buffer is very big and still space is there is no process that is waiting here. So this will, nothing will happen here, no process is waiting in this queue, so nothing will happen. Then this will print key out. So this is open. So now what happens is, this says buffer has been read, right? Hi Sai Kiran has been read, and then we are appending the buffer to with a null pointer, null character, and then we are printing that string. That's what it has come here. So hello Sai Kiran has been printed. So that's what we are printing here in the process. In the process we have printf we have given, right? That's what it is printing. It has read whatever it has read from the other terminal, that is echo has given, that it has read, and it has null terminated it and printed that string here. Now that's what it is there. So now what is the advantage of poll is, so for example, if there are more than one file pointers which have been opened. So now what I told you, right? If now if at all this is ready, now what will happen is it will put a while loop. Two pointers are there in this particular, this one, this structure, poll FD structure. Now it will run on these things. So like if at all any of the file pointer read is available, then it will perform the read on that. If it is not available, so for example in the first thing I showed you, right? So if at all this was, if you write like this without using poll, then even if FD2 the data is available to read, then it will not execute, it will stop here only. But with this, since this one the data is available, so when this will come to this particular point, this will be true and this will execute the read. So there is no blocking. So any one of the file descriptor, any one of the device, if they read, we can read, then we can read it. No need to wait, no need to block on like this, like this. This thing will not happen. So that is the one advantage of poll. So another thing is non-blocking, when it will come is non-block when we will use is, so if at all two processes are there and two processes are woken up to the read at the same time, to read the data at the same time. If one of them reads, the other will not have any data to read, right? In those cases, to avoid the race condition, when one process reads and the other will block, right? So if one reads, the other has to block. because it will not have the data to read. Both the process are ready to read at the same time, but one of them has, because the processor is assigned to it first, it will read first, the other will not be able to read, and so it will block. So in order to avoid that, whenever we will give no node block, what will happen is, so poll will be done. If at all the other process is given the read access first, then it will not block here. So since we have opened it with on block, so if at all the read is not happening, then it will immediately return with this native value. So what will happen is, it will raise condition is just continue, so it will continue. So again it will go here, while loop, again it will poll, it will wait here. So again next time when the raise condition is not happening, at that time then the read will be happening, and then this it will not return a native value, and it will go here and process the data. So whenever the raise condition is happening, so it will return a native value, immediately it will return, instead of blocking here, immediately it will return native value, and then it will continue, and again it will go to poll here, and then again whenever the raise condition is not happening, read will be happening. So that's the idea. So that's all about this. On block when is used when raise conditions are happening, both the process are ready to read at the same time. One of them gets the access, the other will have to block. To avoid that, we are giving on block, don't block, immediately come out. We will try it some other time. We will try when the data is available. So we do some other task. We can put some other task here, and then continue again, try again some other time, after some time later. So like that we can do. So that is on block. So what is this is poll. What will happen is, if at all one of the device, any of the devices is ready to read, that one will be executed. The other so like whichever is available, that one will be executed. That's the one idea about poll. So that's about this. We have seen Scull Pipe code also, and then we have echo we have written in one terminal, and then where the other terminal, the process has been woken up and read has happened. So that's what we have seen. That's all about this. Thank you very much.